What a break. Printf.
Welcome back to Perpetual Jank Machine, the only podcast where we give bad code a good name. I'm John.
I'm Miles.
Miles, how often do you use a debugger? Like a real step-through, legit debugger.
Oh, dude, I stepped through my entire damn program. Like that, honestly, sometimes I like to use the debugger even when stuff is going right, just so I can actually understand what my code is doing.
Okay. That's actually kind of interesting. I'm exactly the opposite. I almost never use a step-through debugger.
Really? Oh my goodness.
Yeah, you commonly use C, though, and C++, so, like, that might be a difference, because
Oh yeah, yeah.
I tend to use GDB, but I don't use any other debugger ever.
Yeah. Well, yeah, you know what? You got a good point there. Yeah, and pretty much any other language, I'm not even putting in the effort learning how to debug you.
I actually have a theory for that. And that theory is that the better a language is at its reading and printing,
Yeah.
and how like high level a language is, and how easy it is to just get something standard out before the program crashes, the less important a debugger actually is.
You know what? That makes sense. Yeah, I guess languages that try to fail gracefully, they do have that luxury of like, not having to worry about everything like disappearing once it crashes.
Yeah, because like with C, half the time you won't even get a printf to work before your program crashes, because it was like UB in the compiler, so the entire thing got elided anyway, or like you
Yeah.
forgot to flush the buffer before you segfaulted, so it didn't, like, it's sitting
Oh
there in the
yeah.
buffer, but it never actually got printed.
If something seg faults, you have no idea where that bug started. Unless like you in the back of your mind you're like, "Oh, this memory allocation seems kind of sketchy."
Yeah,
But like that's the only time whenever you might have an idea where your program seg faults.
yeah, and that's the downfall of like printf. With C especially, printing stuff is really difficult and time consuming because everything is just bits, and there's no nice
Yeah.
representation of anything ever.
Yeah.
In JavaScript or Python, you can just print a list, and see, that's like a second year programming exercise. It's like nicely printing out a list of lists or something like that.
I mean, I think that actually is a programming exercise.
Maybe more of a first year programming exercise, but anything more complex than that. Like if you want to print out like a tree, if it's just a list in Python or something, or if it's just a list in any other language, you can just expand those lists out and kind of see the tree structure grow. With C, you got to get really good at ASCII art really quickly.
You're not wrong. I do the one thing I don't like about debugging modern languages is that the data structures kind of get really large and really absurd because everything has kind of got that pseudo object oriented design where everything's like, a member of something else, and then you got to like print out this variable dot 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 this part of this part of this part of this part.
Hmm.
You got that one like data structure that's like king, and then you gotta, step through all of like its child and then that child's child. And sometimes whenever you don't know exactly what you're looking for, that can be like an absolute nightmare.
That's definitely true in object-oriented languages, but I feel like it's true because everything is its own little parochial type that does not have a good two-string representation. Because like a car class, that car class ain't printing itself unless you give it a two-string, unless you're using like a data class or something new.
Well, like no, like even JavaScript, you know what I'm saying? Like you've got to initialize like, some very complex data structure, and then you're like, where the hell is this going wrong? Like, like I must have missed something, but I don't know where. And then you're like, it's got like 3,000 variables that's like holding on to some URL and like all the data from that URL or something. It just gets very complex very quick.
Hmm.
And I think that can be an absolute nightmare.
That's true if you're working in something that prints to the command line.
Yeah, that's more of an edge case, but yeah, it's very difficult to deal with data structures that don't print out nicely or well, or like, they just like print out their ID number because they're like, there's way too much info in this data structure to actually print out nicely.
Yeah, precisely. I feel like stuff that doesn't print out because it can't print out nicely, like a thread or a coroutine or something, like that's not the problem. But like
Yeah.
if you have a class that contains a lot of actual data that doesn't have a nice textual representation.
Debugging multi-threaded stuff in general is just a nightmare. Even if you have a really good debugger, it's, just obviously race conditions make that already difficult enough. So
Even printf debugging at that point will inevitably slow one of your threads down to the point where the race condition doesn't occur.
that's always a nightmare. Yeah.
The
You're
worst.
like, everything's working perfectly. Oh, I fixed it. And then you delete some print statements. And then you're like, why is everything broken again? Then you put them back and you're like, and now it works? And you're like, well, guess I got a race condition on my hands. At least that helps narrow it
That's
down.
why C and Go based concurrency is a bad idea, kids.
C and Go based concurrency? What do you mean by that?
Mutexes, semaphores, multiple tasks mutating shared data,
Oh,
zero isolation using CSP or immutability.
okay. Well, whenever you fail gracefully, though, that makes it even more complicated because then you have multiple things where stuff is screwing up and it doesn't tell you to like way too far down the line. At least C will like segfault pretty early on. You're like, oh shoot, there is a problem.
C will corrupt memory and keep running in a scary number of circumstances. Like, I think
I
having a
mean,
language with bounds checking at a minimum is probably better than whatever C does.
dude, you're gonna hit null. You're gonna hit something that's 0, 0, or like,
Okay,
like
counterpoint.
going through
That
random
exercise
memory.
everybody did in college. Everybody wrote a memory allocator. If you corrupt the memory in the memory allocator, you're segfaulting like 5 or 6 hops down the line. There's no way you can get back to where you were unless you're
That's
writing
what
some
I'm saying.
kind of.
It's 5 or 6 steps down the line. Obviously not ideal, but like it's way better than something that fails gracefully. And then you won't even know till you try to do something entirely unrelated to that, and then like somehow get screws with that.
Well, there's a difference between fails gracefully and swallows the error. Fails gracefully can like print out a warning and tell you that something went wrong.
I'm kind of the opinion that there is no such thing as failing gracefully. It's all just hiding problems. So that's my hot take, but like,
I agree. Usually failing gracefully means like, at least in most scenarios, still an unrecoverable error has occurred, but like we're just going to keep the program open so that if there's another entry point, you can run things from that.
yeah, it's usually just I can handle a null pointer, and you're like, okay, good thing my entire program is trying to work with a null pointer. That's great. That's
Well,
great.
I mean, it could also occur and you have part of a UI that just is broken, but another part of the UI is working. So you handle the broken bit gracefully, so that way the other part that handles, I don't know, your foos works, but your bars is like totally busted, but you can still like submit the
Yeah,
farm
that's
or
what I'm
whatever.
saying. I don't think that's a good situation at all. I think in 0% of like anything, do you want the UI to not fully break when it breaks? Like when are you like, oh yeah, I can't use that one button, but all the other buttons work. Like when is that a great scenario? Usually, if
When it's
either
already
one
in
or two
production and you
things,
don't want your users to notice.
either one of two things. Either no one uses that button until they need it, in which case you will get a very angry letter from a very panicked person, or everyone is using that, and then that's completely useless because then there's no point in failing gracefully.
Well, there are also other places where you can fail gracefully. Like, let's say a Bluetooth device isn't available, but it will be in a couple of seconds. That's another thing.
That's not really failing gracefully. That's just basically returning your program as, hey, I failed. Like, I tried, I failed. What you gonna do?
Okay, well, getting back to debugging, I still feel like
Which C can do.
C can do that, but in the places where there is a mess up that happens and you catch it five steps down the line, I feel like debuggers are not very helpful for that in that case, because by the time, especially because C is such an imperative language where you can't really rewind time like you can with recursive calls, you're already in a point where the debugger is not going to be useful. You almost need this event log of stuff that happened, and at the point where like you are those 5 and 6 steps down the line, and at the point where your program is like running and not segfaulting immediately, that's where print statements I think really hold value in C, especially.
There are definitely debuggers for C that specifically look for improperly allocated memory and memory leaks and stuff like that.
Yeah, but like logic
And
bugs too. Like maybe you're writing something that kind of manages its own memory in the user space where it's not like you're going to segfault, but it's still a corruption of memory.
there are debuggers for that. They're just really memory intensive, so they're not like general use case ones. I think one's like
Yeah.
vprod or something like that.
Yeah, you can use Valgrind and all that, but
Oh yeah, Valgrind.
if
That's
you're
what it
in
is. Yeah.
a buffer that you legally allocated and like let's say that you're pulling an open SSL and using it for something else for some reason, like that's still not going to catch it because you're still in memory that you own and you're not leaking it presumably.
Yeah, but usually when stuff goes wrong, you're gonna eventually hit garbage memory, and then that's gonna throw to some pointer that's not in the stack, and you'll segfault. But what I'm saying is you'll catch it early on, so it's not some mystery. Oh, where did it go wrong? You at least know. Oh, it went wrong in kind of like this chain of command. You know what I'm saying? Like generally, oh, like in
But when it went wrong in that chain, would you rather have a debugger or would you rather have a trace of like relevant printfs?
I think they both have their appeal. I kind of like the debugger because once you know, then you can just put a break statement earlier on in the whole process and then just step through it and be like, oh, wait, that is completely wrong. That is what that did right there. And now I know where it screwed up right exactly there. So it can be a little time consuming if you've got like a long chain of command and then you're like stepping in, stepping in, stepping in, stepping in for like the next 10 minutes till you eventually hit the bug.
I feel like having everything at my fingertips, like just being able to randomly access like all the lines on my terminal with like all the relevant offsets and stuff like that, way easier to reason about than trying to go through it with a debugger.
Usually you have pretty much the same tools with a debugger. Then, yeah, I think like GDB, you can actually like change stuff on the fly, and you can inspect every single variable and all that.
You can, but
So
it's not as quick. It doesn't give you, like, if you want to go through a for loop, it actually takes you some time in GDB if you have like 100 times. Whereas if the problem occurs on loop 59 out of 100 or loop 60 out of 100, you're just printfing it and you see, like, oh, that offset's wrong. That's like way quicker.
break when I equals 59. You can do something like that.
If you don't know it crashes there yet, then you have to go through 59 useless for loops where everything's working fine.
And I think you can still put a print statement in there. Oh, wait, can you? I don't know if you can add code to it. I actually haven't got that too far. I'm sure you can. I'm sure GDB probably can handle something like that. Well, yeah, you could probably just break, and instead of breaking, you can just print it.
You still have to go through the loop, though. You're still wasting all the time going through the correct steps of the loop.
No, you could do break
I mean, you could set like a
when
watch
I
condition,
equals
but then
59. Yeah, that's what I'm saying. Yeah, if you can do a watch condition, then you can definitely
I'm
just
saying
once
I'm
it
saying
hits
you
there, you
don't
can
know it
print it
screws
out.
up when I equals 59. Like when I equals 59, something else breaks.
Well, I don't get how you're able to print it out when you know something broke. Are you saying just print out everything?
Yeah, just for every single iteration, just print out all the relevant things like the offsets, the pointers, and
Yeah, I
then, you
guess.
can just scan up until something looks wrong. I think that reading that is just a lot simpler than going through like and pressing next, 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 next for all eternity.
Okay, I think most people use print statements before they'll use a debugger. And then once stuff gets a little more complicated than that, then they'll go into debuggers.
I've kind of seen the opposite in my experience. It's like
Really?
the people who like are really experienced tend to do a lot of print statement debugging, I see. And then like the people who are newer tend to like really rely on their debuggers when I feel like it's honestly not the right tool for a lot of situations.
See,
Like just
in
seeing what an
my
object equals or something like that.
experience, when something goes wrong, someone will get angry, and when they'll get angry, they'll angrily write code real quick. You know, like, what did it break? Printf, and then they'll print it out, and they'll be like, none of this makes any sense. Fine, I'll go to a debugger.
Hmm.
I like the thoughtful. Mm-hmm.
Don't know if I've experienced that precisely, but I'll take your
Angry
word for it.
coding?
Your experience is valid. No, angry print
You've
effing.
never angrily wrote down code, man.
I
You're
mean,
like,
yeah,
you get to the point where you're like, I just want this to work. You know what? I'm writing code and I'm not even testing it. I'm just gonna see if this code that I came up with about zero point 0.1 seconds ago and put absolutely no thought into, if this code happens to fix the problem. We've all done that. Dude, I was so elated when that worked. At one time it worked. I was trying to calculate like cosine and sine using like a quartic algorithm, something like that. And I'm like, how do I make this so it works in all four quadrants? And I was just angrily trying everything I could think of. And then one time I was like, I'm just gonna chop off the front bits, the first few bits, and then it just magically solved everything. And I'm like, what the hell? This is working? How did this suddenly start working? It's like, what? And then I went through the code and I started writing down and checking the math. And I'm like, wait, this math checks out. I was working through the proof just to make sure that this wouldn't break later. And I was like, no, this works.
all right, I'll take it.
And I was so happy. I felt like a genius. And by genius, I felt like an idiot because absolute nonsense I wrote down happened to solve a problem. But anyway, that's a completely side tangent. Anyway, debuggers are great. Shut up. Print statements are cool. But we don't have a debugger. There's no debugger for what I'm currently working on. So guess what? It's just print statements. And guess what? Print statements are useful for a lot of things, but I would really like to have a debugger every now and then, just like, as an option. Just saying, really would like that, really want that, really badly, please.
For the past 3 years, I have never wanted for a debugger, ever. I don't even know how I would go about setting it up on my current editor, nor have I cared to look it up, because I just don't feel like I need it.
I mean, if you're doing some of the lines, I feel like mean less on functional languages, because I feel like lines just get out of hand.
Well, that's one of the great things, is if you have a functional language with a good, like, read eval, print loop kind of thing going on, where all the data is easily represented, you can just chuck a function that just print lines it and then just returns the data as well in between, like, function calls. That's what I do pretty frequently.
Wow, this is starting to sound more and more like a debugger.
It's not a debugger, it's just print line debugging, except instead of on a line, you do it in between two calls.
When you think about it, isn't a debugger really just printing out lines when you really think about it?
Well, it's instrumenting the program, and it adds that, like, temporal aspect to it.
Yeah, it actually does a lot. It's one of the few times it actually handles code mutability. Isn't that weird? It's one of the few times code edits itself in an acceptable manner.
In a debugger?
Yeah, I believe so.
Most debuggers I've used don't actually let you edit the source file while it's running.
No, the debugger itself, I believe. It inserts itself into your program. It's one of the few times code is editing code.
Oh,
That's how a debugger works.
well, I mean, a JIT kind of does that too, in that it compiles code on the fly and then comes back into a host program that creates more code to be compiled on the fly. Except with the debugger, obviously, it is doing that for the purpose of debugging things, and it's not necessarily compiling code on the fly, whereas with a JIT, the purpose is specifically that for performance. So, I mean, it's not too uncommon.
Yeah, it's something that's heavily discouraged, but it does have plenty of uses.
You could say that every single Java program is being instrumented by the JVM, because it has to jump back into the JVM and then compile code. I don't know if that's a technically perfect way to use the word instrumented, but I'm sure somebody will let us know.
Words are made up. Words have no meaning. I feel like I'm bad at debugging, because I feel like I rely a bit too much on the debugger, because I kind of just end up stepping through the entire damn program sometimes. And I'm like, well, that was a waste of like 20 minutes because it was on the last line.
That's why I really like the idea of a printf as like an event log. When you start thinking about your programs as transformations of data and logs of events that happened in your system, everything just becomes so much easier to reason about.
Do you ever preemptively add like print statements? Like you set a variable for like debugging mode or something like that?
If I don't know what the type of something is, or like the documentation is wonky, yeah, I'll preemptively print something.
Well, no, I meant like you're writing a more complex system and then you're like writing out a coordinate system or something like that. And then you know that it will get complex. So you want to have a debug mode. Do you ever preemptively add a debug mode to it where you like just have like a Boolean value that you set true or false, and it'll like make it appear on screen like all in red, and it'll show like the wireframe or something, so you can like, not necessarily that, but you get like those types of scenarios.
So I do that all the time in languages that have a good REPL, like Lisps, and to a significantly lesser extent Python, and maybe JavaScript, depending.
Yeah.
Where like I'll just write a pure function and then just call it and make sure it works repeatedly in vitro before putting it into a program.
Yeah.
But for languages that don't have that, I don't even really call it a debug mode. That's the minimum viable product. Like I draw a whole bunch of red squares and then I'll continue to add on to it instead of it just being like its own specific debug thing.
Yeah.
Like I just kind of gradually improve it instead of having a mode that's not what you wanted, but easier to understand, if that makes sense.
I find that I keep deleting that stuff and then I keep rewriting the same print statements and all of that in the exact same spot.
Oh yeah, I comment it out until I know that I'm not going to touch it for a little while. Then I delete them.
I mean, at that point, yeah, don't even compile code with a debugger, right? You know? But wouldn't that feel wrong? Wouldn't you feel evil?
Compile code with a debugger?
Uh-huh.
What?
No. When you're writing code, you're always compiling it with the debug option until it's ready for production. That's the only time you compile code without the debug, unless you are checking for like race conditions or something weird like that.
Mm-hmm.
So if you hate using the debugger, right, that would mean that there would be no point in compiling it for debug.
Yeah, if you don't want to use a debugger for C, then there's no point to use the debug flag. But that also means different things for different languages. Like JavaScript completely just mangles the heck out of the code if you don't compile it in debug mode. So like if you want to use like your sources view or something like that, or you want good stack traces, then that's a big difference. Whereas with C, you don't have stack traces. So that is something to consider. Not using a debugger doesn't mean not using stack traces. That's a little extreme even for me.
I don't like stack traces. I don't like them at all, actually.
Well, a stack trace at least tells you like if you have an obvious error where it happened. That's the important thing for me.
I mean, at that point, you can usually just check where you're returning. You can just step out.
If you're running the program not in a debugger, though,
I guess.
like if you're in a debugger, you already can just step out. But
any point where I would need to use a stack trace, I would rather use a debugger. Like at that point, that's whenever I feel like print statements start to lose their value.
But a debugger is like, you have to already be in the debugger, whereas with a stack trace, it can happen anywhere. It doesn't have to be this prophylactic thing. It can be totally reactive. That's where the stack trace is helpful.
But when does the program stop that you can use the stack trace? You can't just stack trace at any point. Like, I mean, you could, but like by the time you realize something's wrong, you're usually too far gone. So you usually have to run the program again anyway.
You don't need to realize anything's wrong. If you just have like an index out of bounds error, just give you a stack trace there. That's automatic. If you pass something nil when you shouldn't give it nil, you get a stack trace. That's automatic. That's without using a debugger. That's why they're valuable. You can be running it in bloody production mode in some languages, and it'll still give you a useful stack trace if you know where to look.
I can just run it in a debugger usually, and then once it hits a error, it'll just automatically stack trace at that point. Why would I need to specific?
But you don't have to run it in GDB this way. Like, I don't want to start all of my programs in GDB. Like, sometimes I just want to run them.
Why? It doesn't feel any slower usually.
Because I don't want the debugger with my program. Like, sometimes I'm just not running it in my IE. Like, sometimes I'm just running it as a user, and I run into a problem, and the stack trace is still there because it's, a Python program or a Java program or something, and it hasn't been like crazily stripped out. Or in a Java program, I don't even think you can remove those symbols. But that'll still get logged. So if you're looking in your service logs, you get the stack trace. And it'll tell you where the problem is, what caused the crash in that log for that thing running not in a debugger, because you cannot run a production service in a debugger.
I mean, yeah, I guess, but at that point, you're basically always running a debugger. Like, that's just a debugger. Like, it's kind of like you're saying you want to not use a debugger by just always using a debugger.
But that's not a debugger. It's not instrumenting your program.
But you just said with Java, you can't even take those out, and they're always there. That is a debugger, bud. It's just always running in debug mode.
Well, no, you're not instrumenting your program. That's not something outside the scope of your program. Your program is doing that. Your program is saying, hey, I ran into an exception. Let's unwind the stack. That's something that your program is calling. As part of the library, yes, you didn't write it.
It's kind of just like it's already got the hooks in there. Whenever you compile for debug, doesn't it just add hooks that the thing uses to instrument it?
Well, you can debug a program compiled in release mode. It's not something inherent to the program.
Yeah, but then it has no way of telling what is what. At that point, it's basically just as if it's like stepping through assembly.
But there's no change in the program. The debugger is the thing that instruments it. The program is not instrumenting itself.
Yeah, so it's kind of like you're always compiling in debug mode, if that's what you're saying. It's kind of like you're always debugging.
But you're not. It's not an external program that's doing it. It's your program that's causing that behavior. That is like a desired feature. I don't really think
it matters whether it's built in or whether it's external. I think it's the same thing. And it is kind of, like you said with Java, it is kind of an external thing. By recording a stack trace, it's already built in. It already has performance implications. The only difference is in like C, you can actually choose to remove those things.
The JVM does not have any of this instrumentation stuff that a debugger has that lets it step through and step in and step out. When it's compiled in that manner, it just goes.
No, even like Java, it's just interpreting your code. It could stop at any point it wants to and just tell you what line it's at. Like that would take no additional overhead. That's just the way it works.
Well, how would you tell Java to stop the program at that point? If you're in JITted code, then...
Well, oh yeah, no, I guess Java does compile.
You need to compile a jump or a ret or something into there.
But it's already got the stack traces, so it already knows where it's at. It's not, and it knows the variables that it's working with. Okay, let me just mangle words, like, use them completely improperly. It kind of feels like modern languages are just always running with a very light debugger if you really want to use words wrong.
Okay, I will concede in that sense. It's not running a full fat debugger, but it is running.
It's running like debugger light. Yeah, it's
if it's in a JIT or if it's in an interpreter, it is kind of sort of technically being instrumented. Yes, I agree.
So what I'm saying is those luxuries that you were provided are kind of debugger-esque. So in a way, it's kind of like you're using a debugger if you really want to use words wrong, which I love to do. I love to use those words the wrong way.
All right, I will agree with you on that much. I still think DAC traces are useful, though, because you get the convenience of a debugger without the overhead or, oh god, I don't even want to think of the security concerns of running something in a debugger in production. Oh boy, that'd be a fun one.
Guess what, bud? I am sure lots of code is out there in the wild, compiled to debug mode. You have no idea.
Compiled to debug mode is fine. Actually running in GDB, I think that would be another concern entirely.
I mean, I guess you need the source code usually for the debugger.
You can just GDB any old binary that you want.
Well, no, I'm saying to properly debug. Like you have to have more than just compiled to debug mode. You also need to.
Okay, well, define properly. If you're reverse engineering something, then are you properly debugging it?
Yeah, no, you kind of are. You kind of are reverse engineering your code whenever you're debugging it, because you're like, okay, I know what I was intending to do, but what is actually doing? So you kind of are.
So what if you're like reverse engineering like something that somebody gave you? Is that proper debugging?
Yeah, I've debugged plenty of code that I didn't understand because it was someone else's. I'm like,
so then you would say proper debugging does not require source files.
Proper debugging does not require source files? I guess so.
Because if you're debugging a program that Adobe gave you against their terms of service, I think.
I've tried to do that. I failed miserably, don't get me wrong. But occasionally I'm like, you know what? This bug's irritated me enough. I kind of want to see if I can figure it out myself. That way I can just be like, hey, it's right here. It's right here. Please fix this for me. I know where it is and I know what's going wrong. Please.
Like the guy who solved that quadratic JSON parsing in Grand Theft Auto that was causing everybody's CPUs to pin a core forever.
That was beautiful.
That was great.
Oh my goodness. That was amazing. I'm telling you, occasionally you run into bugs like frequently enough and people just won't listen to you, that you just, sometimes you're just like, I'll do it myself. I swear. Just please.
You got to whip out that computer science degree and start
decompiling code just so you can figure out what's going wrong. If you want to use words wrong again, debugging code is just reverse engineering it. So,
and that's the show. Thanks to Meydän, that's Meyda with an umlaut N, for their track The Beauty of Maths, licensed under the Creative Commons Attribution 3.0 license, which serves as our intro, outro, and interlude music. You can find more in the description of this episode. Please remember that the opinions expressed in this production may not reflect those of other participants on the show, or those of any participant's past, current, or future employers. They're also probably exaggerated a bit for comedy's sake. Anyway, thanks for tuning in.